Alright, let's get started with the solutions for exam 2. So the first few questions were conceptual questions. First question which is not one of the 7 sources of waste. Well, remember, price is not a source of waste. Price is what balances supply and demand. The next question was, Iowa Health is interested in calculating the overall equipment efficiency of their MRI machine. Which item is not needed for calculating this? Well, to calculate the OEE, we really don't care about the efficiency, actually energy efficiency. We would not even care about the machine's efficiency, because OEE itself is a measure of an efficiency. So there's no point using some other measure of efficiency to calculate efficiency, right? So Sunbucks Coffee owns a chain of coffee shops. They are interested in balancing their workforce so that they serve the customer better. Which item is not needed for takt time calculation? Well, customer wait time is not needed for the takt time calculation. Well, takt time calculation is just the ratio of how much time you have available versus how much product you have to make in that time. Brown Lobster is a restaurant chain running 200 restaurants around the world. They're interested in computing the labor productivity in their restaurants. Which item is not needed? Well, labor productivity has nothing to do with the cost of ingredients. It's just how much product you make divided by what labor input goes in there. Alright, this was an interesting question, and almost nobody got it perfectly correct. There were a few which was very, very close. The first part is how many new fits are conducted in a typical day. This was the easier part of the question. Let's think of this as a little slow problem. What we know here is at any given time there are 7 procedures happening, right? And then each procedure takes 2 hours. Well, put that into little slow. I equals to RT, right? Think of this procedure as your process going from in here coming out. This whole thing takes 2 hours. If we think of it that way, at any given time, if you look at the system, there are 7 people being served. So you want to find the rate, right? And the time is 2 hours. That means the rate is 3.5 customers per hour. But we have 14 hours in a day, so 3.5 times 14 gives you 49. But you also know not all of them are new. The interesting part here is the new fits, because the question tells you that about 2 out of the 5 customers are refits. So that means 3 out of 5 are new customers. 3 out of 5 of 49 is 29.4. So 29.4 customers are new customers. What is the OEE of the wind tunnel? There are multiple ways to think of this. The most natural way to think of this is how much service you provide versus how much value you add versus. So this is value added. This is value that could be added, possible time, right? Value that could be added, possible value added. Possible value added is pretty easy, right? Possible value added is pretty easy because we know it could run for 10 days, it could run for 24 hours, and at any given time 7 people could get served, right? That part is fairly easy. How about the value added? Well, refits are not value added, that is rework. So what's happening is only 29.4 people are being add value every day. To that many customers, the value is added every day. For each customers, even though we work for 2 hours, we have to subtract this 20 minutes, because 20 minutes could have been done outside. So it's really about 2 hours minus 20 minutes is 0.33 hours. So 1.67 hours of value is added per customer. So 1.67 hours, right? Times, if you can do this 9 days, this is how much value is being added in that 10-day period. This is how much value could have been added. So you can find the ratio. It comes about 26.3%. Alright, the next question is, if you have 15.5 hours of production time available, and the customer is demanding 720 cases per day, what is the takt time? Well, takt time is available time divided by how much you have to produce in that available time, right? The amount you have to produce in that time. The easiest way to think about takt time is this. So available time is 15 hours, 15.5 hours. Let's convert this into seconds. So minutes and seconds. How many do you have to produce? Well, 720 cases. In each case there are 6 units. If you get this, this is about 12.96 seconds per unit. So that means you have to produce 1 unit every 12.96 seconds so that you can meet the customer's demand. Which of this is a flow-centric waste? Well, everything is a resource-centric waste except for the weighting. A furniture company produces 200 tables and 800 chairs a day. Standard selling price is $90 for table and $35 per chair. Payroll cost is $100. Material is $5,000 and overhead is $720. Find the multi-factor productivity. Well, multi-factor productivity, or any productivity for that matter, is just output divided by input. So here output is $200 tables times $90 plus 800 chairs times $35 divided by the input is $10,000 in payroll plus $5,000 in material cost plus $720 in overhead. This comes out to be about $2.93 per dollar. So every dollar you spend, you get about 2.93 times. That's a pretty good deal. All right. First, you gotta draw the project network. Well, let me draw the simple project network here. Well, A and B don't have predecessors, so we can just go ahead and make A and B. A and B don't have predecessors. So if you want to get it, make it simple for you, you can have a start node. So a start node, as there is no predecessors for A and B, it goes from start nodes. Well, C has a predecessor A, D has a predecessor B, let's see, E has a predecessor C, F has a predecessor C, G has a predecessor D and E. So G has a predecessor D and E, and then H has a predecessor F and G. F and G. Well, if you want, you can have a finish node. That's all that is. Well, identify the critical path. Well, to identify the critical path, now we have to do this whole thing in a much more sophisticated way. Let me do this here. All right, let me make the rectangles that you are used to. Just rewrite what we made earlier. All right, we had A here first. Let me make these boxes first. 2, 3, 4, 5, 6. All right, let me use a different color now. Let me use blue here. All right, so this is A, and the processing time is 2. B, the task time is 3. C, the task time is 2. D, the task time is 4. E, the task time is 4, F, the task time is 3, G, the task time is 5, H, the task time is 2. Let me make this black. So we have a path going from A to B, B to D, A to C, C to F, C to E, E to Z, D to G, and then G to H and F to H. Alright, that way we have less crossovers. Alright, let's do the forward pass. Let me use a slightly different color here. Well, alright, A and B don't have predecessors, so we can get started on A and B right away. So 0, 0. So 0 plus 2 is 2. 0 plus 3 is 3. So C has only one predecessor, so we can get started on C right away. So 2 plus 2 is 4. Let's go to D. D has only one predecessor, so 3 plus 4 is 7. F has only one predecessor, so you can just take this 4 here. 4 plus 3 is 7. E has only one predecessor, so 4 plus 4 is 8. G has two predecessors, so we have to take the maximum of 8 and 7, so 8 and 5 is 13. H has two predecessors, F and G, so we have to take the maximum of 17 and 3, 13, 7 and 13, so 13 plus 5 is 13 plus 2 is 15. Or you can do the backward pass again, but to answer the first question we have, well, we can't answer that, sorry. So now let's do the backward pass. So 15 minus 2 is 13. So we, as F has only one successor, so we can just bring the 13 here. 13 minus 3 is 10. G has only one successor, so you can just bring the 13 here. 13 minus 5 is 8. E has only one successor, so you can just bring the 8 here. 8 minus 4 is 4. C has two successors, so you have to bring the minimum of it. So 4 and 10, you bring the minimum 4 to 2. D has only one successor, you can just bring 8 here. 8 minus 4 is 4. So this 4 here and 1 here, 2 here and 0. Alright, now we are ready to identify the critical path. Before identifying the critical path, we can see the slack. So the slack is 0, 1, 0, 1, 6, 0, 0 and 0. So the critical path is the one that follows, let me use a different color here, let me use blue here. So the critical path is that follows 0, 0, 0 and 0. So your critical path is A, C, E, G and H. Identify the activity to be crashed by a week. So now to identify the path, to identify the activity that will be that needs to be crashed by a week, it has to be one of these 5, because we know crashing any other activity doesn't make any sense. But which one to crash? We have to find the lowest cost to crash. The lowest cost to crash, again, we are really interested on A, C, E and G, H. A, C, E, G and H. Well, let's see. The cost of crashing A from 2 to 1 is the difference between 20,000 and 20,700, that is 700. C is 25,000 and 26,100, and that is 1,100. The difference between the crashing cost of C, 4 and 2, remember we can be crashed twice for 2 weeks. So the difference here is 2,000, but because you can be crashed 2 weeks, so we have to divide it by 2, so it makes it 1,000 per week. Z, the cost of crashing Z is per unit is again here 5 to 3, so there are 2 weeks that can be crashed. The difference is 1,800, so 1,800 divided by 2 is 900. H can be crashed by 1, and the difference here is 2,900. So the cheapest one to crash is A, because A is 700. It costs only 700 to crash. So the activity that should be crashed is A. Right, crash A. Next question asks, what is the total cost after crashing, right? What is the total cost including the crashing cost? Well, that part is pretty easy. Well, all you got to do is you got to add the normal cost, add the normal cost. This comes out to be 299,000. So by adding the crashing cost, you add this 700. So the total cost is 299,000 plus 700 comes out to be 299,700. All right. The next question is, it's actually a really simple question. What's the probability of finishing the project under 200 days? First, we have to find what's the normal value. In the PERT calculation, the normal value, there are many ways to think about normal value. Either you can look at the last activity and look at the latest finish or earliest finish. Both are 194. The other way to do this is look at all, given that there's only one critical path, add the mean processing time of all the activities in the critical path. You will get 194. So the mean completion time is 194. What this is telling you is the mean is 194. The standard, now we want to find the project completion time for 200 days, right? Now we need the standard deviation. Well, to find the standard deviation, what we need to do is to find the standard deviation. This is usually the hardest part. Standard deviation of critical path is the square root of sum of variance of critical path activities, right? So the variance of critical path. So what you do is you add all the variances in critical path. So in our case, it is 53.77 plus 9 plus 5.44 plus 4 plus 13.44. You get square root of 85.65, and the square root is 9.25. Again, the reason is you can't add standard deviations. You have to add variances and get the square root of it. After you do that, it's a fairly straightforward process. The standard deviation here is 9.25. Let me use a different color here. Well, you have to find the equivalent of this in a standard normal, the mean of 0 and a standard deviation of 1. You have to find this equivalent of 200, and that is what we call G. So Z is nothing but 200 minus 194 divided by 9.25, right? You want to find the equivalent of G. All you got to do is 200 minus this 194 divided by this standard deviation. Comes out to be Z of about 0.6486, and if you look at the G table, it is about 74%. Okay, so that's all there is. So the probability of finishing the project within 200 days is 74%.